a new flavor in your ear. I'm kicking new flavor in your ear. Like a brand new flavor in your ear. Here comes a brand new flavor in your ear. Yes, it's always time for marketing analytics flavor in your ear. Hello, this is Eric Riney from Webster University coming at you again with another marketing analytics procedure. In today's tutorial, we're going to be discussing cluster analysis. Let's get started. So the best way to get started with discussing cluster analysis is to look at an example and just discuss how we actually think about classification. So in this example, you see the various shapes that we have here, and there are a number of ways that we could actually classify these. One obvious way, of course, is by the actual shape. And so here we could classify by square, circle, and triangle. Another way we could classify is by color. So here we have yellow, green, orange, and blue. Another very obvious way of classification. However, in many circumstances, when we're segmenting or classifying, we don't want to do so with obvious variables such as gender, age, race. While those are easy and those are, just a knee-jerk reaction approach that we normally take when we're segmenting, oftentimes those don't produce the quality segmenting that we would want. And in many circumstances, we want something that looks at perhaps the value sought or the type of usage or the amount of usage or lifestyle. These are more effective variables that we should begin classifying on. And one of the things I want you to realize, not that, a cluster analysis is necessarily going to identify the variables that you need, but I want you to be aware that you should always be cognizant of the variables that you're using. So similar to our example of classification, a cluster analysis does a similar thing, but it does it on a more complex level of taking variables and a variety of variables and multiple variables and using them to try to create clusters. And basically, it's a data reduction method used to classify a large number of observations into manageable groups. And that's basically what segmenting is. It's a geometric approach to determining distances based on quantitative variables of interest. So again, what we're trying to do is measure the distance between members and identify members that cluster together or are similar, or from a geometric standpoint, their distances are close together. And at the same time, try to create groups that are distinct or have distance to each other. The wonderful thing about a cluster analysis is that you might find some hidden similarities that may not really be easy to identify. So a good cluster analysis is going to produce really high quality clusters that have homogeneity within the group. In other words, there's going to be high similarity between the members of the group. At the same time, we want to have groups that are heterogeneous from each other. In other words, they're distinct from each other. And this is what we want when we're doing a segment. The segment, the members within the group should be very similar to each other. If they're not, why are we grouping them together? And at the same time, they should be distinct from the rest of the market. If they're not distinct from the rest of the market, why are we segmenting them? This is similar to when we do a cluster analysis. This is our goal. The quality of the cluster analysis is really going to depend on a couple of things. One, the type of cluster analysis that we conduct. There are multiple ones that are possible for us to conduct. And also the variables that we use. So the number of variables that we use, the type of variables that we use, the quality of those variables can all play a significant role in terms of giving us high quality clusters. There are different types of cluster analyses. There's a hierarchical cluster analysis, a non-hierarchical cluster analysis, and a k-means is one type, and that's what we'll be using today. And then there's a combination or a two-step analysis, which combines, in many cases, a hierarchical cluster analysis and then a non-hierarchical cluster analysis. Okay, before we start the cluster analysis, it's good to just talk through the steps of doing the cluster analysis because this can get very complicated, and it's really good to understand all the steps necessary and kind of do a checklist as you go through to make sure that you're following the process correctly. So as with any analysis, the first thing you want to do is make sure that you've identified the correct analysis. So if in fact you've identified that the cluster analysis is the appropriate analysis that you should conduct, then you can begin the checklist. So first we want to identify what variables we'll be using in the cluster analysis. We can have various factors that are available, and it's good to understand what is important in your analysis. So if we were doing a cluster analysis on segments, race may not necessarily be that important, or age may not necessarily be that important. In certain circumstances they are, in other circumstances it might be something like lifestyle or value sought, or perhaps use are typical variables that we might cluster on. So that's the first place you need to start. In order to have an effective cluster analysis, you need to make sure you're using the correct variables. Next, you want to determine if the variables are in the same scale of measure. And sorry about that, I have IIN there, but in the same scale of measure, and oftentimes you'll see that they're not. You might have one variable that might be on a 7-point Likert scale. Maybe it's information we got from a questionnaire or something. You may have another scale, often the same questionnaire maybe, but maybe it's an age, and it's an open type of question, and you're allowed to put in a range of ages from 0 all the way up to 100, or however old someone is. You might have another scale that is income, and maybe it's open, and you could have income from 0 all the way up to 200,000 or $1 million. So having those different scales can impact the weight of the variables and the measure on the scale, on the cluster analysis. So if we have these different scales, we want to standardize them so that they all have the same amount of weight in the analysis. All right, and we'll be discussing that a little bit later. The next thing is we want to determine how many clusters we want to actually do in our analysis. So you can have, 2 clusters. So think of this in terms of segments again. If we're segmenting the market, maybe we want to segment the market into 4 segments or possibly 5 segments. Certainly, depending on the number of variables you have, that can impact the number of clusters that you're able to do successfully. Not that you couldn't possibly do a high number of clusters with 2 variables, but it's a little bit more difficult. The more variables we have in our analysis, the more robust our analysis could possibly be if we're in fact using great variables, and more likely the more clusters we could use. I'm going to demonstrate to you doing a number of different clusters and comparing the results of those various clusters, and you can kind of in your analysis see, what the right number of clusters might be. All right. The next thing you want to do is that you're going to actually, in your analysis, in your Excel sheet, you're going to create from these centroids, you're going to identify some centroids that you can cluster on, and then you're going to use those centroids to determine distances from your other measures, or I'm sorry, not your variables, but your other cases. So if we're talking about individuals, if we're talking about businesses, whatever we're looking at in our analysis as different cases or observations, you're going to measure the distance for each one of those observations to each one of the centers or centroids that you're using, and determine which ones are closer. And if you remember correctly, the goal in a cluster analysis is to find center points that are kind of like stars that really draw a lot of planets or a lot of cases, a lot of observations around them, so that they are very similar in nature, but at the same time, they're distant from other clusters. And that's our goal, to create these clusters that are really close to each other. The observations are close to each other, but they're distant from other clusters. And we're going to do that by measuring the distances. And we'll talk a little bit more about how we'll do that. And the way we'll do that is by looking at sum of distances. And ultimately, what we're going to do in our analysis is we're going to use solver then to try to figure out how we can minimize our sum of distances. In other words, minimize the distances within those clusters in a way that creates really strong, tight clusters. All right, so those are the steps that we are going to go through. And then I have here kind of for each one of these more detailed information. And I'll use this. I'll go back and forth between this and my actual Excel sheet in order to explain what I'm doing. All right, so that's it. Let's now go over and start actually doing our cluster analysis. All right, so now let's go over to our actual data sheet and let's begin going through a cluster analysis so I can explain to you how we actually conduct a cluster analysis. And the data sheet I'm going to be using is borrowed from the Marketing Analytics Data-Driven Techniques with Microsoft Excel by Winston. This is a Wiley textbook. And we're going to be using from their Chapter 23 Excel sheet on cities. So this is what the Excel sheet looks like. And basically, it has a list of cities. I believe there are 49 cities here throughout the United States. And they give the percentage of different racial categories, so Black, Hispanic, Asian, as well as median age, unemployment rate, and then per capita income. So we have these variables that we now could possibly use in order to figure out how we could cluster these cities based on these variables. So that's what we're going to do. So first step, identify the variables you're going to use in your analysis. More variables should hopefully lead to more precise clustering. However, make sure variables are important attributes of interest or significant factors to use for clustering. And in the case of cities, racial profiles percentage of race of the population may be something that's really important. Certainly age, median age, unemployment, income level are all things that we might look at in terms of looking for cities that are very similar to each other. And the reason we might do this in marketing is that perhaps we have certain products that we're looking for certain profiles, and so we want to see where we could successfully launch these particular products. And if we could find a cluster of cities that are similar, maybe we can launch the product there. And there may be certain circumstances where perhaps we've done a test market and we've identified certain places where the product has been successful, and we want to launch it in cities that are similar to that. So we might also do a cluster analysis for that reason. All right, so in this circumstance, we're going to use all of these variables in order to do our clustering on. All right, so what's the next step? The next step then is that if we go up here, determine if the variables are in the same scale of measure. So percentage, of course, is going to be on the same scale. If we have percentage, it's from 0 to 100%. So that is going to be on the same scale of measure. However, median age is not on the same scale as percentage. And unemployment rate is not on the same scale, and neither is per capita income. And you can see this is in thousands of dollars, okay? So that means we are going to have to do a z-score, or what we call a standardization of the measures. So that's one of the things that we want to do. Now, if we were only doing it on these percentages, we wouldn't have to standardize because these are all using the same measure. So we're going to standardize. And how do we actually standardize? To standardize, we need to calculate a mean and a standard deviation for each of the variables that we're going to use in our analysis. Then from there, we can actually use this standardized formula, which takes our observation for the variable, the mean, which will calculate the standard deviation for that measure, which will also calculate that particular variable, and then it'll give us a standardized score. All right, and this is the formula for a z-score. You're probably familiar with this from maybe statistics or your research class or something like that. So this is something that you find quite often. All right, so we're going to begin this process. I'm just going to start up here and type in standard deviation, and I'm going to try to follow what they've done in the textbooks in terms of how they've set this up, so you could follow along with how things are in the textbook, and do it that way. All right. So I'm sorry, we want to start with the mean score, and then we also want to do standard deviation. So I believe that's how they have it set up in the textbook. And we're going to do the mean score and standard deviation for each one of our variables, and basically want the overall mean score for percentage of Black, the overall mean score for Hispanic, and so forth. And we want the standard deviation for each one of these. So again, you can come up here and do a formula equals average, open paren, and I'm just going to select the entire range. If you've actually labeled these, then you could use that as well. I have not labeled them. So we can see that the mean score here, and I'm actually going to move these up. I thought I started in the first row, but I didn't. I'm just going to cut and paste. Like I said, I want to make sure that I'm setting this up the same way it's set up in the textbook. All right, so the mean percentage of blacks across the cities is 24%. All right. The standard deviation, and if you remember, standard deviation is the measure of variance within whatever we're measuring. So it's how much deviation there is of these various measures in comparison to the mean. All right, so we're going to calculate standard deviation, and it's just STDEV, open paren, and again, we're going to select the entire column of cities, and we see our standard deviation here is 18.11025. All right, so now we have our mean score and our standard deviation for the percentage of blacks across all the cities. Since I have this, I can now copy this all the way across really easily, and it'll transfer across because Excel does a wonderful job. As I shift over, it shifts everything over. So you can see it's moved everything over in terms of my scores or what it's measuring. All right. So now we have the standard deviation and the mean for each one of our variables. So let's go back over here to the steps and let's look at what we need to do next. So now we need to create a standardized score. All right, this standardized score is going to be for every observation or every measure for every city on every variable. We need to standardize the score. In other words, for each one of these measures, Albuquerque, for percentage of blacks, for percentage of Hispanics, and so forth, we're going to standardize each one of these scores so that it's on a similar scale. So I'm going to come over here and create another column that I'm going to call a standardized column or a Z column. So I'm going to say Z black for the percentage black standardized, Z Hispanic, and so forth. So I'm going to pause and fill this in real quick, and then I'll come back and start after I've done that. All right, so I've filled in all of my column headers. So now I can go in and actually create the standard, using the Excel formula, create the standardized score for each of my measures. So here equals standardize, and you can see here that as soon as you start typing in STAN, it'll offer you up the formulas that are available. If you double click on it, now it's going to say, okay, what do I need first? I need the X. The X is the actual measure for that particular item. So here it's Albuquerque percentage of black. That's what I want to get the Z score for. I want to standardize that measure. So that's my X value, comma, the mean score. What's my mean score? This is my mean score up here. And what I want to do for my mean score is I want to lock this in place. I want to lock this row in place. So I am going to lock the 1 in place by putting a $ in front of it. If you put a $ in front of the C, you're also locking the column. But I do want to be able to copy this across, and I want the column to shift. But as I go down, I don't want the row to shift. So I'm locking the row in place. You could do this with the F4 key. I'm just typing it in so you could see exactly what I did. All right. Now that's my mean. I'm going to hit comma, and now it's saying what's the standard deviation for this particular variable, and we have that here. And again, I'm going to lock this in place by putting a $ to lock the row in place. And I'm going to close that formula off and hit enter. And this is now my standardized score. So a standardized score of 3 would be negative 1.17872. And now what I can do is I can copy this down the entire row and get a score across all of the variables. Okay, so I've copied this down, and you can see where I have my z-scores for all of my percentage of black for each city. And now I can just copy this across. And now I have all of my z-scores, and just to kind of verify that things shifted, if I place my cursor inside, I can see, yes, look at that. Everything moved over nicely. Let's just try another one and see. Oh yeah, perfect. Let's go over here. Beautiful. Yes, indeed. So now I have my standardized scores for each one of my variables for each city. So we are now done with the standardization. Okay, so now let's go to the next step, and we can see that we need to figure out how many centroids we want, so that we can actually determine our clusters. And since the textbook uses 4, we're going to use 4 clusters to begin with as well. And the way to set this up is that we are going to just arbitrarily identify some cities to start with, and then we're going to use Solver to eventually identify the correct cities. So the first thing we have to do is actually set our table up to do this. And one of the things that I mentioned over here is that we want to make sure to actually, if I have it, I thought I have it here, make sure that we actually count. Here we go. Note, you will need to identify column number to be sure to have the column numbers available for the cluster analysis. So that's one of the things that we're going to do as we're setting this up. So just keep that in mind, that we need to number the columns as we're doing this. But I'm going to try to set this up exactly the way they have it in the textbook. All right, so one of the things they have is to identify the column number. They have this row here for column number, and I'll explain that. I'll come back to it. And then we actually have our centroid, our cluster that we're going to be working with, and we're just going to say 1, 2, 3, 4. So those are going to be our clusters that we're going to use for now. All right, so that's just going to be the city number that has been assigned to each city. So you see each city has a number. And what we want to be pulled in from this is the actual city name. And then also we want these variables to be pulled in as well. So I'm just going to copy these headers up here. All right. So for this first city number, which is Albuquerque, I want Albuquerque to be pulled in here. And then I want the z-score for Black, z-score for Hispanic, Asian, and so forth to be pulled in up here. So as this number changes, I want these to be able to change as well. So what we're going to use to do this is what's called a VLOOKUP. And the VLOOKUP allows us to do exactly that. Look up something in a data range and then pull out from that data range something else, all right? And the way it chooses the something else is that we actually have to have these column numbers, and that's one of the things that I was talking about before, where we need to make sure that we actually have column numbers here. So the data range we're going to be using is this entire data range, because this VLOOKUP is going to look up this first column, right? So that's where it's going to pull in and find the 1. It's going to look it up in this column. So that's column 1. And then I needed to find the Z score for black and pull it up here. Well, what column number is that? So if we just count over 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 9th column. So up here, I'm just going to identify this as 9, which means this is 10, 11, 12, 13, and 14. All right. And for the city name, it's going to be column number 2. And I'm actually not going to put 2 up here, but I'm going to hard code it in here. So here, instead of hard coding, I could hard code it in here, but instead, just to do it the way the book has it set up, I'm actually labeling these columns. All right, so how do we do the VLOOKUP? We say equals VLOOKUP. And it says, okay, what value do you want me to look up? So I want this to be looked up, and then comma, it takes me to the next point in the VLOOKUP formula, and it says, okay, what's the array? What's the table that I'm using? So I'm going to use this entire table right here of information. So I'm just going to highlight the entire table, and you could do, if you wanted to, this first column. It doesn't matter in this case. Either one will work. Now, since this table is not going to shift or change, I'm going to lock this in place. I want both the row and the column to lock in place. I don't want this to shift at all. And again, if you were to do this using the F4 key, you could do it all at once. All right, so I put $signs in front of both my letter and my numbers for the starting point and the ending point of the table array. I've hit comma, and now it says, okay, what is the column index number? In other words, once I find the number in this table, what do you want me to pull in from? And in this case, this is city. It's the second column. So we're going to say pull in the second column. All right. And if I hit comma and hit enter, look at that. Albuquerque is pulled in. If I change this to, I have 27 here. So let's try 27. Milwaukee is pulled in. Beautiful. It's working perfectly. All right. So now that I have this, I should be able to now just copy this down, and let's see if it works correctly. Let me scroll back up. Yes. Look at that. Albuquerque, Atlanta, Austin, Baltimore. Albuquerque, Atlanta, Austin, Baltimore. And if I change this to a 12, it's Denver, and that is Denver. And let's just try one more here. If I change this to 18, it is Houston. And look at that, Houston. So this is working perfectly. Just change these back to 1, 2, 3, 4. All right, so my VLOOKUP is working well for my city. Now I have to do my VLOOKUP over here. And I'm just going to copy this over, and all we have to do is just change a couple of things and we'll be set. So I'm just going to copy me try that again. Copy. And right now it's saying NA because it shifted my number over. So I'm going to shift this back over to make sure I'm looking up this 1. I want to look up this 1. Now I'm going to copy this across. So I want to make sure that as I move from the Z Black to Z Hispanic, this number doesn't shift over columns. So I'm going to lock this H in place. However, as I copy this down, I do want my rows to shift. So I'm not going to lock the 5 in place. Again, my table is already locked in place. Here, in terms of my column index, now I don't want 2 here. I don't want this column. I want this column. And I'm just going to use this because I know for Z Black, the column is this. All right. And I'm going to lock this row in place again. Well, in this case, it's going to be the row I'm locking in place. So as I shift over, I do want the column to change, but I want the row to stay the same. I hit enter. And look at this. If we go back up here to Albuquerque and we look at Z Black, it has been pulled in up here. If I change this to, let's go to 5, which is Boston. Boston comes in for the city name, Boston Black. You can see that little over 9% is the, well, I'll say the standardized score is 0.09. It's not a percentage anymore, but 0.09 is now the Z-score that's pulled in for Boston. So this is working perfectly. All right. So now I can copy this across, hopefully, and it should pull everything in. And look at that. It's done it beautifully. All of our scores are the same. All right, so this is working, and if I copy this down, I'm just dragging down. Let's see, is this working right? It looks like it is. Yes, look at this. Absolutely. And then if I pull in Boston again, which is 5, just gonna highlight this so I could see 09, 0, negative 218. 09339. Yes, it's working beautifully. Let's do 5 here. Let's do 5 here. This is an easy way to check to see if it's working. Yes. So now we have our starting point for determining how we are going to identify the centroids. And remember, our goal is to find cities that are stars or center points. Really, these would be identified as the cities that seem to be the center of a cluster of cities that are so similar to it that it's almost like a star. It's almost like the sun that's pulling in a lot of other planets around it. All right. So that's our goal. We're going to try to figure out which one of these various cities will kind of represent the other cities around it. All right. Now, this would be very difficult for us to do by hand, and definitely would not be at all possible if we tried to just eyeball this. There's just no way we could do this. And so that's why we're going to use Solver as an analytical tool to do this for us. All right. But in order to get this measure to happen, what we need to do is that we need to measure the distance of each of our cities compared to each of the centroids. And so that's the next step we're going to do. Okay, so the way we're going to do this is we're going to use a measure called sum of squared distances. And this is similar to what we do when we're calculating variance. right? It's taking the difference between two scores, which is typically the observation and the mean, and then squaring it to get rid of the negative sign, and then that will give us a measure of the distance, all right? So we're going to apply that same logic here. So the way we're going to do this is we're going to create some columns to do the sum of difference for each one of these centroids or clusters, right? So we're going to have a sum of distance or sum of difference is the way they actually label it in the book. I just looked at the book for cluster 1, and let's wrap this. All right, and we're going to have this for all 4 clusters. And if I drag this across, yep. One of the beautiful things about Excel, if it sees a number, sometimes it will look at that as a count, and it'll adjust for you. So as I drag that over, it went from cluster 1, cluster 2, cluster 3, cluster 4. So basically what I have here is the sum of difference for cluster 1, which will be this one. And if you get confused here, you could put cluster 1, cluster 2, cluster 3, cluster 4, just so that you know. Or if you really want to get fancy, you could make this adjust so that the actual city name is in here. But we're not going to worry about that right now. All right, so what I need to happen here for this first observation, which is Albuquerque, I need to do a sum of differences score for all of these variables compared to all of the variables for the first cluster, which happens to be Albuquerque. So in this case, there should not be any difference because it is the same city. So there is no distance between the measures here. But let me show you how this is set up. This is a formula called sum x my2 is what we're going to be using. So equals sum x my2. All right. Sum x x2y and then square that is basically what it's saying. All right. So it's saying, okay, what's my x array? So my x array is actually going to be my cluster. And in this case, I don't want this cluster to move. As I move down this column, I want this cluster to stay in place. All right. So I am going to lock this in place. And again, you can use F4 if you have on a Mac. I think it might be Command F4. I'm not sure. All right. So I now have identified my first array, my X array, and now it says, okay, compared to what? And I want to compare it to this right here. All right. And in this case, I am going to lock my column in place because I don't want this to shift over. So as I go down, I want this to go down for each of these cities, all right, because I'm going to compare each one of these cities to Albuquerque. But as I shift over, as I shift down, I want these to shift down, but I don't want them to shift over as I shift over, okay? So as you can see, 0 as expected. So there is no difference between Albuquerque and itself. So this in fact is not going to give us much information. But if I copy this down to the next one, we do see that there is a score here. And now it's comparing Albuquerque up here. And let's just highlight this. Albuquerque, which is my centroid, to Atlanta. And it's giving me a sum of difference scores. All right, so really quickly, let's just take a look at this so you can see exactly what's going on here. So I'm just going to copy this up here really quickly and show you what's going on. I'm just going to copy the actual ranges here and put these labels up here so you know what we're talking about here. All right, so Albuquerque, all I did was copy this z-scores for this first centroid, which is Albuquerque. And now I'm going to copy Atlanta here, which is what we have in our measure of sum of differences squared. So I'm just going to copy this right here and just do a paste special and paste the actual numbers in. All right. So remember, what this is a sum of differences. So basically what it's doing is it's taking the difference between, and I'll type in Atlanta here. So, all right, it's taking the difference between these scores, and then it's squaring that, and then it's summing them. All right, so I am going to do that. Let's just take the difference. Equals this minus this. All right. So this will be diff, and then this will be diff squared. I'll just put the hat so you know it's diff squared. Equals this square. All right. So this is my not sum of difference, but this is my difference squared, and then I'm going to sum this up, okay? So now I can copy this across and get a measure for each one of my variables. And that's what I'm going to do. All right. Now that I have that, I can actually do my sum of differences, sum of diff squared. And all I'm going to do is sum these up, equals sum and there you go, 18.20017, and that's how this is calculated. All right, so this is giving me the distance, the overall distance when we're looking at these variables between Albuquerque and Atlanta. All right. If I were to do this, let's copy this down again to Austin. And we see that it's 3.68. So in other words, the distance of these measures, these variables with Austin compared to Albuquerque, Albuquerque and Austin seem to be a lot more similar than Atlanta and Albuquerque because the sum of differences is a lot smaller. So that's how you would interpret that. And if I were to just copy this Austin really quickly, just so we can verify that this is actually the case, I'm changing this to Albuquerque now, or I'm sorry, to Austin. You can see 3.68. So it's working well. All right. So now I can just copy this all the way down. And I see that my measures are, hopefully working correctly. And I could go back and make sure that this, in fact, is working the way it's supposed to. Now, I want the same thing to happen over here, except now I want in cluster 2, I want Albuquerque here to be measured to whatever my second cluster is. And my second cluster is Atlanta. So I should have the same score here that I would here because, in fact, Atlanta is my second cluster up here. I'm just kind of switching these. All right. So I'm going to go up here. All I'm going to do is just drag this down because now I want Atlanta to be my center. And you can see, look at that. These two are the same. And now if I copy this down, Atlanta, since Atlanta is 2 and Atlanta is my center, it's going to be 0. Perfect. It's working well. So now I'm going to copy this across again. And I have to change my cluster, my centroid, because I want this to be 3 instead of 2. Right now, I copy this across and I have this locked in for Atlanta. But all I have to do is just drag this down. And now I could see that I'm comparing Albuquerque to Austin. And Albuquerque to Austin here should give me the same thing. Let's make sure we're doing this right. Austin and Albuquerque, and if I go here to, here we go, Austin and Albuquerque, I have the same measure, so it looks like it's working well. If I copy this down, look at this. Again, it's going to be 0 here because it's comparing Austin to itself. It looks like everything is working well. And I'm going to copy this across one more time. And I'm going to drag this down to, let's try that again. Put our cursor back up here. Drag this down to the next cluster or centroid, which is Baltimore. And if I compare it to what Baltimore is here, yep, looks good. And I can drag this down and we should have a 0 here. We do. So all of this is working perfectly. So now I have all of my sum of difference measures comparisons when I'm looking at these centers or these centroids to the various cities. So if I were to change this to Boston, it should shift up here to Boston, and what it's going to do down here is now shift this cluster to Boston. And you can see here now Boston is 0. That's one way I can make sure that things are working correctly. If I change this to 16, which is Fresno, yep, Fresno changed up here. Looks like that's working well. And down here, look at that, Fresno changed. And so now, looks like everything is working the way it's supposed to work. Awesome, really good news there. All right, so I'm going to delete this because I was just using that to show you how this sum of differences works. And now what we need to do is actually go into identifying the minimum distance or the minimum sum of differences, or which one of these centroids is going to be the closest for each one of our cities. So of course, Albuquerque is going to be closest to itself, and Atlanta is going to be closest to itself, and so forth. But if we go down here to like Boston and we look at these different measures, we can eyeball this and see that Boston seems to be closest when we're comparing it to these 4 centroids. It seems to be the closest to Austin because that's the lowest sum of differences. So what we want to do is we want to identify where the minimum distance cluster is. So we're going to start a new column over here, and we're just going to call this minimum difference, or minimum distance, I'll say. And let's wrap that. All right. And the way we do minimum distance is pretty easy. It's just minimum. It's min. You have a max formula. You have a min formula. And min formula just identifies what's the lowest value in a range that you identify. So equals min, open paren. Okay. What are we comparing to find the min? And this is the range. And I'm going to close that. And you see here, of course, it's 0. I can drag this down. And all of these are going to be 0. But here, as I mentioned for Boston, the min is this cluster 3. So now we have our min identified for each one of these. We now see for each one of these, based on the clusters that have been identified, and remember these are arbitrary for right now. We could have put anything up here. But you see what are the minimum centroids for each one of the cities. So for Chicago, it looks like cluster 4 is the minimum. All right, so it looks like everything is working perfectly. So now we have our sum of differences, and we've identified the way for us to actually point to the centroid that is the minimum distance. All right, so the next thing we're going to do is now identify which of the clusters this minimum distance belongs to. All right, the way we do this is we're going to do a match function. All right, and basically what we want to say is, hey, okay, you've identified the minimum distance. Now, where does that belong? Which one of these does that belong to? All right, and that'll just help us be able to identify which cluster each one of these. So we don't have to go over here and say, okay, this is 4.21. Where is that? Oh, that's here. That's cluster 3. Instead, we could just look in this column and in fact get that information. So that's what we want to be able to do. So the way we do this is we use our match function. All right, and match, it says, okay, what value do you want me to look up? I want you to look up this minimum value, comma, and I want you to match it in these data points. So in this lookup array, I want you to find this and tell me where it is. All right, so I'm going to hit comma here. I don't necessarily have to put any locks in place here because I'm just going to copy this down, and I do want this to shift down. And in this case, I want an exact match. So I want a 0 here for exact match. You could just type in 0. In this case, I just did double click on my mouse and did it on my left mouse. All right, so now it should tell me that the match is this first column, and this is going to do a match of the column, and this is column 1, column 2, column 3, column 4, which just happens to match with cluster 1, cluster 2, cluster 3, cluster 4. All right, and that worked perfectly. And if we copy this down, we should see 1, 2, 3, 4 in these first ones, and we do. Now after this one, it's no telling what we'll see. So 3 here, let's see if that's true. Yes, cluster 3 here, saying cluster 2. In fact, that's right. So now we've identified the cluster that is the best match. Now if we go back up here to our cluster, and I'm just going to select different clusters. So 11 here is Dallas, and let's choose 16, which is Fresno, and let's choose 6, which is Boston. And now you can see that we have things have changed significantly here. So Albuquerque now is closest to this first centroid, which is Dallas, when we're comparing it to Fresno, Charlotte, and Baltimore. All right, in other words, when we're looking at the percentage of blacks, percentage of Hispanics, Asians, the median age, the unemployment rate, and per capita income, then Albuquerque is most closely aligned or most closely associated with Dallas as compared to these other 3 cities. All right, and you can see that with the rest of these. So now we have almost everything we need in order for us to actually do our cluster analysis. The only thing left we have to do is we need something that the solver can solve for. All right. And in this case, what it's going to solve for is the minimum distance. So we want minimum distance. Remember, our goal here is to find the minimum distance that each one of these cities represents in these clusters. So what's going to happen is that as we change these cities, of course, it changes these minimum distances. And as these minimum distances change, then our overall distance will change as well. So we need a score of the overall minimum distance. So we're just going to call this sum dis squared. All right. And it's just basically going to be a sum of this column of minimum distance. I'm just going to sum that whole column up. All right. So right now with 1, 2, 3, 4, we see that the minimum distance across all of these measures is 310.70. If I were to change this, I'm just throwing in some different arbitrary things in here. We could see that, let's put 16 in here and 5 in here, that now the distance has increased to 275. So we actually had minimum distances using 1, 2, 3, 4 than we do using these particular cities. But now what we can do is have solver solve for minimizing this by changing these cities. And what's going to happen is that it's going to identify the cities that create the most minimum distance in measures. All right. So there you have it. We are now ready to go and actually do our data analysis using Data Solver. Okay, so let's go back over and look at our steps and make sure that we've done everything correctly. We did our standardization, our standardized rather, score. We've created our centroids, and we've done our sum of distance measure. And now we can actually begin to do our data analysis to try to figure out which cities will create the centroids that will minimize the sum of distances. All right. And the way we go about this is that we're going to use Data Solver to do this. So you go up to Data, you go over to Solver, and what we want to happen is we want Solver to minimize the sum of distance score by changing these various cities, right? So it's going to just kind of scroll through these cities and, look at comparing all of them to each other and try to figure out which one is going to create a sum of distance measure that is minimum. And here we want minimum. All right. Now we do have some constraints that we have to put in here. For one, we want this range right here to be less than or equal to 49. And the reason for that is because we have only 49 cities. So we don't want this to go over 49, or we're not going to have any variables to identify or use to measure. So you want to make sure that you have the range of scores possible within the context of your analysis. So we're going to add this, and we also don't want this to be less than, we want this to be greater than or equal to 1. So the lowest we want it to be is 1. The highest we want it to be is 49. So we 49 equal to or less than 49, greater than or equal to 1. I'm going to add that. The other thing we want here is that we want these to be whole numbers. We don't want solver coming back with a 1.25 or 3.47 or something like that. So even though we've established the ranges between 1 and 49, there are a lot of different numbers that are not just 1 through 49, but 1 point, numbers. So we're going to establish this as integer, and I'm going to hit OK. And now we see it's got to be greater than or equal to 1, less than or equal to 49, and we want to make sure that the numbers are integers. And we're going to use evolutionary here. And if you remember in the book, it says that you should use evolutionary engine when it gives you this really complicated explanation of the idea of containing non-smooth functions, but it then specifies if you have, count ifs or sum ifs or max mins or averages or things like that. We have all of these in our particular Excel analysis. So we're going to use evolutionary for this. And then we hit solve and we let it run. And this is going to take some time to run. So I'm going to hit pause on my video. Oh, look at this. It did not take very long at all. I thought it would actually take a little bit longer than that. So never mind. All right, I'm going to hit continue right quick and just see. All right. Sometimes it'll come up with something and it says maximum number of sub-problems reached. In certain cases, if you don't set it for a high number of iterations, then it might reach it really quickly. You want to set that pretty high, especially if it's going through really quickly. And you could hit continue a couple times to see if this changes. If it doesn't change, you know that you've actually reached the minimum in terms of distance. So I'm going to try this one more time and let's see what we get. And you see now that it is taking a little bit longer to go through. So I'm going to pause and I'll come back shortly. Okay, so it finally finished, and you could see here that you've really reached the final result when it says solver cannot improve the current solution. This is different than before where it just said you reached the minimum, you've maximized the number of iterations. In this case, it's saying it can improve. It's tried to improve. It's gone through more iterations and can improve it. So we'll hit OK, and we'll see what we're left with here. And you can see here that the sum of distances is 165.3482. The last time I hit continue, it was 166. So it did improve it a little bit. You can see the cities that have been identified for these 4 different centroids, and we have Omaha here, San Francisco, Memphis, and Los Angeles. And we could see, you could kind of scroll down if you wanted to see which one of these is assigned to which city is assigned to which centroid. And so now we've actually done our analysis, but this in and of itself is not good enough. I mean, we have to be able to summarize this information, interpret this information, and be able to present results in a way that is going to help the people who are asking about this information. So while we have done the necessary analysis, we need to in fact do the last step. All right. So that's what we're going to do now. Okay, so there's a number of ways that we can actually summarize this data. And I've created a summary sheet, and I'm just going to walk you through how I summarize the data. For one, the textbook does this right here where it has identified the various cities that belong to each one of the centroids. So LA, Omaha. So if you go back up here, LA, Omaha, San Fran, and so forth, it has in fact listed the ones that belong to each one of the centroids. You can see LA has, fairly large number. Omaha has an even bigger number. Memphis, not so big. And then we have San Francisco that has really only two others besides itself. And maybe this is an indication of maybe not having great variables. It could be an indication that, hey, these are just outliers and they're very much on their own, and they're different from everything else, and this is what you got. I mean, you're just going to have some segments that are smaller, or some clusters that are smaller than others. So I don't want you to think that the clusters have to be equal in size, because just like market segments, you're going to have different sizes. Same thing with clusters, you can have different sizes. You want clusters that are meaningful and effective in terms of you being able to use the information to do marketing. So that's the goal here. All right. So, I mean, this gives us a little bit of information, but I like to take this a step further. One of the things I want to be able to do is know, all right, what does this LA really mean? What does this Omaha really mean in terms of these variables we're looking at? You can't tell up here what it means because these are the standard deviations, and so they don't really have much meaning to us. So what I've done is I've actually created a table for each cluster, and basically all I'm doing is I'm taking, those factors that we're using, those variables that we're using. We have 4 different clusters, so I'm doing this for each one of the clusters. I'm totaling the cluster, so I'm saying how many cities are in the cluster. So if we look at Omaha, go down here, we can actually count that there are 23 cities that make up this, and you can see down here the count is 23. So it gives me a total count in the cluster, and not only that, it gives me what the average is for the percentage of blacks. So in this cluster, the average percentage of blacks is going to be 17. The average percentage of Hispanics is 9. The average percentage of Asians is 2, and so forth. So I'm doing an average of each one of my variables across the cities that are in this cluster. Now, how did I do that? Basically, what I did is I just said, hey, if Albuquerque has been identified as being in this cluster, then give me the actual numbers that make up the variables for Albuquerque. So if you look here, it says if T10, what is T10? That's back over here where it says what number was it assigned? Oh, it was assigned 1. If it was assigned 1, that's this first cluster, which is Omaha, right? So if we go here, cluster 1 is Omaha, San Fran, and so forth. So cluster 1, if it's in cluster 1, then pull it in here and give me the actual numbers back over here. So our original variables are being pulled in. So I have my original numbers over here, and you can see this for Albuquerque. We see that Austin here is also, if I go here, we can see Austin is also being pulled in. And so I'm doing that for each one of these clusters. We see San Francisco only has 3 in it. Memphis has 11 in it, and Los Angeles has 12 in it. So now I have a summary measure of what each one of these clusters looks like. All right, and now I've done a summary of results up here, and basically I'm just pulling in these summary results up here, and now I have a table that I can really closely do a comparison and see what's going on. So Omaha has 23 cities, 17% black on average, 9% Hispanic on average, 2% Asian on average. Medium age is 31, unemployment rate is 5.13%, and the per capita income is $20,000. And you can compare that to the other cities. Now, one of the great things about having this summary table and being able to compare this really easily is that you can kind of see possibly where the differences really lie in your variables. For instance, if we look at median age, the age range here, while there's some differences, is pretty close. So median age may not necessarily be a tremendous factor, at least in comparing the cities that we have here. So if we wanted segments, or if we had a product or a service or something, and we wanted to identify segments or cities based on age, then based on this analysis, we may not necessarily have a great result here. I don't know. It depends on what you're looking at. And again, this is median age. All right. So some of the factors that seem to stand out really are the percentage of the racial category. So we see that Memphis has an extremely large black population, minimum Asian, and even Hispanic, right? So, I mean, that stands out when you compare it to these other cities. Omaha has, decent percentage of blacks, but, relatively decent compared to the other ones, except for Los Angeles. Hispanic population, still a low Asian population. But here we see that San Fran has an extremely large Asian population compared to the other ones. And Los Angeles has the highest percentage of Hispanics compared to the other centroids. So you can see, in terms of racial makeup, how these centroids are made up. Again, age may not necessarily be a huge difference. Unemployment rate, we do see some significant differences, at least between the bottom two and the upper two. And then per capita, a little bit of differences, but not much. So one of the things that you might want to do here is possibly break this up and do one cluster analysis just on racial profile, and then you might consider doing another cluster analysis on median age, unemployment rate, and per capita income, and you would probably come up with different cities and maybe broader age ranges here. But it looks like these have such an impact that they're in many ways creating more weight in some instances than these over here. But across the board, we see that there are some differences, when you're comparing these different clusters or centroids. All right. And again, remember, these are the averages across all of the cities that have been identified in each one of these clusters. All right. So that gives us some valuable information then that we could take to marketing executives or marketing managers or people that are wanting this information and use it. So if we wanted to report this, the way we would report this is we would say a cluster analysis was conducted in order to identify clusters of cities. Four clusters were used, or four centroids were used in order to do the analysis. Results indicate that Omaha, San Francisco, Memphis, and Los Angeles create the centroids for each one of the clusters. If you want to go into details about these results, you could. You could say Omaha had 23 cities identified in its cluster as compared to San Fran, which only had 3, and Memphis and Los Angeles with 11 and 12. And, you could also report some of these other numbers as well. And that's basically your cluster analysis. All right, so what I've gone ahead and done is created a cluster analysis using 3 centroids and one using 6 centroids. So you could see a comparison to this one that has 4 centroids. So if we look at the 6 centroid solution for the cluster analysis, we see that Omaha is still there. Now, if you look at San Francisco, Honolulu has been pulled out. So the Asian has really taken over there, and so has the age. So the median age is much older than the rest. So it looks like Honolulu is an outlier here. San Fran is still here, and if we were to go over to San Fran, you could see what else is in the San Fran category. And if we highlight this row just so we can see what this is, it's San Fran, and what's the other one? The other one is Seattle. So Seattle, San Fran, the same as it was before. Only thing is now Honolulu is pulled out. El Paso is now a new one. It only has 3 in it, and we can look and see what that's about. But again, Hispanic is huge part of the makeup of this cluster. And the sum of this is 128 compared to 165, but I don't want you to really look at the sum of distance as a measure of the cluster analysis being better, right? We're using more centroids, so the sum of distance is probably going to be smaller because there's more opportunities to create smaller distances between the cities. But you can see here that, maybe these 3 cities and this 2 and this 1, this is probably a good indication that maybe using 6 clusters is not really effective for us. So then I went and did 3, and I wanted to see what the solution would be with 3. And you can see here that with 3, we still have San Francisco. San Francisco, Honolulu, and Seattle are just, they stand on their own. And it looks like they're always going to be a strong center. But we do have San Diego, and Kansas City and San Diego, I'm sure, has taken over for Los Angeles. San Diego may be a little bit more central in terms of these other 16 cities. I say 16 because San Diego is part of this, so it's the 17th city. But it may be a stronger center for these 16 cities compared to Los Angeles. And then we have Kansas City, which now has come out, and there's 29 cities, and this may be like a Rust Belt or kind of a central United States cluster, if we were to look at it. Charlotte, Chicago, Cincinnati, Cleveland, Columbus, all of those are right there included in this. And you see Austin, Albuquerque, Dallas, El Paso, Fresno, Fort Worth, Texas are all part of this San Diego. And those look like those are pretty strong clusters in terms of three cluster solution. Maybe this is better than the four cluster solution. Again, it's up to you to make a determination of the robustness of the results and how well they're going to help you to be effective in whatever it is you're looking to do, whether it's to launch a product or advertising or, distribution, who knows. So one of the other things I mentioned was that you might want to do a separate analysis where you didn't look at the racial profiles and you only looked at age, unemployment rate, and per capita income. So I actually did an analysis looking at those three, and I used the four centroids, the original four centroids, and we see here that El Paso is still here, but we have very different centroids here. We see the racial categories are still prevalent, even though we didn't use these in our cluster analysis. So even though I'm using this in my summary, and that's the difference really. So when we're talking about segmentation, it's one thing to segment on a variable. It's another thing to use descriptors of those various segments. So in this case, these would be descriptors of the segment, and these would be, they're also descriptors, but they're at another level because they're actually what we're segmenting these different clusters on. All right, but as I was saying, you can still see that it looks like race still plays a significant role, and that's because, especially with unemployment rate and per capita income, we see that there is a strong correlation between those and the different racial groups. But here we can see that we do have a little bit more variance in terms of unemployment rate than we did previously. And even with the per capita income, there's a little bit more variance going on. Here, still age doesn't seem to be that significant or prevalent. There may be some significant differences here, but it doesn't look like, it's just having that much of an impact. And so we may want to consider whether or not we even use age in our analysis. We might be able to come up with something even stronger if we eliminated age. But again, these are just the various things that you need to really look at in terms of trying to decide how well can I use this information, and what other variables do I need to bring in? Don't just take your analysis on face value, right? The analysis is just numbers. It's crunching numbers. But it's up to you to make sure you're using the right information to crunch numbers, and also making sure that you're interpreting those numbers correctly and that you're presenting them well. So there you have it. That's the cluster analysis plus, kind of a more in-depth look at how you could do cluster analysis. Again, my name is Eric Riney from Webster University. You can contact me at my email information. You can also contact me on Twitter or LinkedIn, and certainly you can find me on YouTube. Join me for another one of my marketing analytics videos. There are more to come. And if you like this one, hit the like button. And you can also join my page. Take care, and I'll see you soon.
Time for new flavor in your ear. I'm kicking new flavor in your ear. Like a brand new flavor in your ear. Here comes a brand new flavor in your ear.
Yes, it's always time for marketing analytics flavor in your ear.